In this lesson, we look at managing BIG-IP ASM devices. First, we cover the discovery of ASM devices. Then we will examine the creation and management of an ASM security policy from BIG-IQ, and finish with managing learning suggestions and other policy management tasks from BIG-IQ before we apply our new knowledge in some labs. AVR, LTM, and ASM must be licensed and provisioned on the BIG-IP device. The left side of the diagram shows a typical setup of BIG-IQ and BIG-IP ASM. An administrator may have several BIG-IP ASM devices or virtual editions in the network. Rather than logging into the configuration utility on each device separately, BIG-IQ can pull and update ASM configuration data from a device and then edit and replace it on the original device or duplicate the data to another ASM device. On the right side, the BIG-IQ Web Application Security Policy Editor Policies screen lists application security policies discovered on BIG-IP devices. Each security policy is assigned a unique identifier that it carries across the enterprise. This ensures that each policy is shown only once in the policy screen, no matter how many devices it is attached to. As it relates to ASM, we can break BIG-IQ functionality into three areas. Discover BIG-IP ASM devices and display the ASM-related objects that are found. Edit the discovered ASM objects or create new ones and deploy them. Monitor the discovered ASM devices and report on or display the state of their objects and various functionality. Let's look at discovery. We need to find the devices we wish to manage. It's a two-stage process. First, discover the target BIG-IP device. BIG-IQ connects to it, installs a base REST code, retrieves its hostname, software version, and other basic information. The second stage is device services discovery. BIG-IQ knows that potentially the BIG-IP can have ASM installed on it. So is the device we discover in the first stage actually running ASM? We do a secondary discovery of the services running on that unit and find out. Let's see how this looks in the BIG-IQ GUI when discovering. After clicking Add Device, fill in the IP address used to discover the target device or system. This can be the management IP address or a self-IP on the target system. If it's the self-IP, make sure ports 22 and 443 are open. REST calls are encrypted. BIG-IQ makes the initial connection, then displays a selection of products or services. Note, however, that not all selections might be licensed or provisioned on the target device. The first part of discovery completes. The BIG-IP system and LTM and ASM have been discovered. Once we have reached the target and made sure the REST code is installed, look around the BIG-IP device and find out if any ASM objects exist. We can import them to BIG-IQ. Once objects are imported, BIG-IQ screens are populated with whatever was found on the target, such as VLANs, virtual servers, and pools for LTM, and application security policies and profiles of various kinds for ASM. Here are some but not all of the objects that are now available on the BIG-IQ once the import has completed. Sub-collections are groups of like objects related to the Web Application Security Policy. Not all sub-collections are visible in the Web Application Security Policy Editor. Other sub-collections can be imported and deployed without being displayed. Generally, you can import sub-collections from a BIG-IP device and then deploy them without editing. After discovery, the configuration area shows what has been discovered. The pictured example displays just a few of the possible menu options, providing an example of where ASM lives in the BIG-IQ menu. With the import complete, ASM objects are now visible in the GUI in various places. ASM components are grouped under the Web Application Security tab. All discovered BIG-IPs are listed under Devices. Virtual servers are listed if they were discovered on the BIG-IP device after LTM discovery and import, or if they were created on the BIG-IQ device. The inactive virtual server appears after the ASM service is imported. It exists as a container for any ASM policies that are not assigned to a virtual server yet, and will be listed even if no ASM policies have been created. The presence of that inactive virtual server is actually a clue that ASM services were imported at some point. Signature sets are the default signature sets also imported after discovery. Attack signatures are the default attack signatures included with BIG-IQ. Let's look at deployment. Deployment follows the same model as LTM. Create ASM objects or make edits to existing objects, then deploy the changes. Using BIG-IQ, the workflow for policy deployment is very similar to working directly on the BIG-IP. First, we add a policy and configure its basic properties, such as name, application language, and other tasks that should be familiar to an administrator. Then we can review learning and blocking settings, configure any additional mitigations such as those for anomaly detection, like brute force, and configure event logging on the DCD. Then we can run traffic and tune the security policy from BIG-IQ. ASM administrative tasks on BIG-IQ are similar to the traditional configuration utility. You can add or create, import, export, and delete security policies. Additionally, BIG-IQ allows you to clone and deploy security policies from the Policies screen. With basic properties configured, select a policy configuration attribute from the Settings pane on the left, which reveals editable sections on the right. After initial policy creation is complete, BIG-IQ displays the general properties as shown here. View objects related to this policy by clicking the Show button. The related items for each policy include attack signatures, devices, and attack signature sets. Items such as devices must be imported before they will appear on this list. If more policy modification is desired, click the name of the security policy. The top part of the blocking settings section controls the broad enforcement mode, learning mode, and learning speed for the policy. However, we also have to decide to use either local or centralized policy building. Let's define these next. The policy builder running on each BIG-IP ASM device generates learning suggestions based on traffic secured by the security policy on that device. In BIG-IQ, this is called Local Policy Building Mode. Centralized Policy Builder, or CPB, makes learning suggestions for policy building based on traffic the BIG-IP policies encounter. In the GUI, this is called Central. If configured to use central policy building, rather than their own local policy builders, the BIG-IPs do not use their own policy builder to alter their own policies. Instead, policy building on each BIG-IP device is managed by the BIG-IQ. CPB, which resides on a data collection device and monitors the traffic seen by the BIG-IPs, will now make all the policy changes in the form of suggestions that are subsequently sent to the BIG-IQ. If these suggestions are accepted on the BIG-IQ, the policies on the BIG-IQ will be automatically modified. These changes must then be deployed to the BIG-IPs. Step 1. Click your ASM policy. Step 2. In the Policy Building section, click Settings. Step 3. By default, Policy Building mode is local and suggestions will appear on the BIG-IP. Select Central. In Step 4, it's recommended to select your DCD, although you can auto-select a DCD that is on the network. First, select your policy. Second, click Suggestions and locate them in the list on the right. Accept suggestions, then evaluate and deploy from BIG-IQ back to BIG-IP. The Policy Building Overview page is where the admin can view and change various aspects of policy building by clicking the expanding menu. The first section displays devices which are being managed via centralized policy building. A shortcut to the Enforcement Readiness Summary page provides links to the Learning page for entities so you can take action. Brute force attack protection can now be configured on BIG-IQ and deployed to other BIG-IPs. As on BIG-IP ASM, this setting is under anomaly detection and includes a default profile. Layer 7 DOS profiles can also be created and deployed from BIG-IQ. The detection and mitigation options are the same as on a BIG-IP ASM device. We have just looked at BIG-IQ discovery and deployment for BIG-IP ASM. Next, we look at some of the monitoring facilities that are available on BIG-IQ. We'll see some of these in the labs as well. Before an administrator can see request logs from ASM on the BIG-IQ, a data collection device must be configured. A DCD is a specially provisioned BIG-IQ system running the same software build as the BIG-IQ device where you manage your security policies. After provisioning the DCD, discover it from BIG-IQ and add the service. One or more BIG-IP systems send their logging events to a DCD, and the BIG-IQ system can retrieve logging events from one or more DCDs. This is the process. A logging profile defined in the BIG-IP ASM and assigned to a virtual server replicates the requests to a DCD. The logging DCD acts as a repository to store all the requests arriving from the ASM logging profile. BIG-IQ connects to the DCD, pulls the information, and displays requests from all virtual servers. BIG-IQ displays all requests stored in the DCDs. Here is the request log with the illegal requests filter applied. From this page, you can export requests in a CSV file and review full request details. Requests cannot be deleted. The BIG-IQ DCD uses separate services for management and traffic. It is recommended these are kept on separate networks to reduce unnecessary congestion. In the lab, we use the internal network for traffic between the DCD and ASM. The self-IP address on the DCD then listens for log traffic from the logging profile on the virtual server. Before starting the labs, remember that LTM, AVR, and ASM must be licensed and provisioned on the target BIG-IP device. Also note that the required browser for the labs is Google Chrome. After discovering a BIG-IP ASM device, we create and deploy a virtual server, then create, assign, and deploy an ASM policy. We configure ASM event logging, then finish by testing the ASM policy and examining enforcement and learning modes.